Hi, my name is Philip Lynch and I'm CEO of Pixel Soup, and we're just at the end of a day of UX testing, and I just thought I'd share with you how we got on. We use a thing called a Tobii eye tracker. This is where it tracks a child's eye movement when they're actually playing the game itself, and we use it in a particular mode called rotational symmetry. So we use it to validate the learning objectives within the game itself. And what I'm going to do now is I'm going to put it on, I'm going to show you the video, and I'm going to do a voiceover as well, just talk you through what's going on. So let's go have a look at it. I'm just going to pause the game here for 1 second just to introduce you to some new data that's on screen at the moment. These 3 new red dots. It's important to note that these red dots are not part of Symmetry School, the game itself, but what they are is some data from the Tobii eye tracker to give you an indication of where Matthew's eye has travelled during the gameplay. So there's 3 red dots on screen at the moment where I've paused it. It started off in the bottom left hand corner, and then that one is connected to 2 other smaller dots that are hovering over the English selection button in the centre of the screen. This is where Matthew started looking, the bottom left hand corner. He made his way up to the English selection button, made sure it was that, and then selected this section. You'll notice that the data from the red dots from the Tobii eye tracker are getting larger the longer that the child is staying looking in one area. So you see this purple triangle is working on at the moment. It's getting really large at the moment. That's called a dwell point. That gives an indication of how long Matthew has stayed in that area looking at that particular counter while he assesses what orientation that counter should be in. So he's looking on the light blue ones now, and you can see that he's staying in that area, and it's getting huge. So he must be there about 3 or 4 seconds. The longer he stays, the more he's concentrating on the orientation of that particular counter. So then also you'll notice that he's mapping back and forth to the original counter, where he's using that as a reference on which way, not just where it should be placed, but also which way it should be orientated. So he's nearly finished the hexagons now, and he should just then map back to the the green triangles. Okay, let's have a look at how he gets on the green triangles. Yeah, okay, not bad. You can see him referencing the original green triangle. You can see it going down to the original one, getting it in the right orientation, then going back to the loose counters on the left hand side, putting it in the right place, and then this last green triangle into the bottom right hand side of the board, and that's it. The well done screen came up as summary of how he got on. His target moves were 15, so he could have done that in 15 moves. He did it in 21, and not by placing any of the counters in the wrong place, but by simply moving off some of the counters without orientating them into the right position, or the right orientation, I should say. So his time was 1 minute and 33 seconds, and you can see I've just paused it exactly where there's a little dwell point in the bottom right hand corner. As I said, the dwell points are hugely important. They give a very clear indication of how long Matthew has stayed concentrating on some of the shapes that were presented to him and turning them around in his head to work out which way they should be pointing in the correct manner. And this is rotational symmetry.